All right, so another example from graphing inequalities. This time we are going to graph a system of inequalities. Once you can graph a single inequality, this is really no different except that what we're going to do is we're going to graph both of these on the same Cartesian plane, and then we're going to identify what the solution set is that satisfies both. So we're going to go through our 3 steps for both of these inequalities. The first one is x is greater than or equal to 6 minus 2y. So step 1 is I am going to graph the equation. So x equals 6 minus 2y. This is just a line, so I'm going to solve it for y. So first thing I'm going to do is I'm going to subtract 6 from both sides. Then I'm going to divide everything by negative 2. And so I've got 1 over negative 2, so negative 1/2 x. Negative 6 over negative 2 is plus 3 is equal to y. So I've got a slope of negative 1/2. I can put the negative with the top or the bottom. It doesn't matter. And then I've got a y-intercept of 0, 3. Now, if you'll allow me, I'm going to get both of these graphs so that I don't make you dizzy going back and forth to the graphing board. So I'm going to do step 1 for this next graph. I've got x squared equals y. Well, this is just my basic parabola. There's no stretching or shrinking. There's no translation anywhere. So I've got my y equals x squared. So I'm going to go to my graphing board. We're going to graph both of these, and then we will do our shading. Also notice before I twist, both of these have a equal sign to them. So that's going to affect what kind of line. So coming over to my graphing board, first thing I'm going to do is graph the line. The line had a y-intercept of 3 and a slope of negative 1/2. So the y-intercept is 3. 1, 2, 3. I'm going to make a dot here. And then the slope was negative 1 over 2. So down 1, right 2. Down 1, right to 2. And then down 1 more, right 2. And we could do that all day. It's very fun. And then I have an equals. So I'm going to connect these not with a dotted line, but with a solid line. So here we go. I'm going to do my best. Okay, not bad for not having a straight edge. We'll come back. Well, let's do this. We might as well do this one at a time so that I don't get too confounding. So I'm going to go back to my other board. I need to know which way am I going to shade for this line. Am I going to shade above or am I going to shade below? So once again, just because it's my habit when I'm able to, I'm going to pick the test point 0, 0. So I'm going to come back over here. I'm going to erase the work for step 1 because we've already done it. And so I'm going to test, for step 3, I'm going to test the point 0, 0. So when I put 0 in for x, I got 6 minus when I put 0 in for y, I've got 0 is bigger than or equal to 6. That is a false statement. Okay, so false. So that means when I go back to my graph, here was my test point 0, 0. This was false. So that means I'm going to shade up here. So that's my graph so far. Now the second graph was just our basic parabola. There was no stretching or shrinking or anything done. So I'm going to plot the points for the basic parabola. Vertex of 0, 0, over 1, up 1, over 2, up 1, 2, 3, 4, over 3, up 1, 2, 3, 4, 5, 6, 7, 8, 9. The same thing on the other side of the axis of symmetry. 1, 2, 3, 4. There we go. And then over 3, up 9. Looks good. And so then again, there was equals. So I am going to connect these with a solid line. Okay, so now the other thing that remains is I have to see where am I going to shade with respect to the green graph now. So I'm going to come back over here. So again, I'm going to use, well, I can't use the test point 0, 0 this time because the graph goes through it. So I'm going to use the test point 0, 2. I'm going to go up 2 units on the y-axis. So we are going to test 0, 2. You can pick anything as long as it's not on the graph. So 0, 2 was not. So when I put 0, 2 in, 0 for x is 0. 2 for y is 2. This is a true statement. 0 is less than or equal to 2. So I come over here. We're almost done. Notice the graph went through 0, 0. So I picked the test point 0, 2. And I got a true statement. So that means I am going to shade inside the parabola. So then the question remains, what's the solution? Okay, so we've graphed both. We've got the purple graph, we've got the green graph. When you are finding the solution to a system, remember when we were doing a system of equations, the solution is where the two graphs intersect. Well, this is the same thing. Where do the graphs overlap? And so we see right here that out here I've just got purple. In this little bitty bit here, I've just got green, but I've got both colors inside the parabola down to this part where the line cuts across and then up. So I'm just going to shade this in a different color. You can make it darker if you're just using pencil. On the test, please just, if you don't have different colors, just let me know where the solution is by using an arrow. And that region right there is the solution to the system of inequalities.